In this segment, I'm going to introduce the idea of lexicalizing PCFGs. So let's look at our basic PCFG here and see how the probabilities of rules actually work. So what we have in the PCFG is local trees corresponding to rules such as verb phrase rewrites as VBD, PP, and that has some probability attached to it, like maybe that probability would be 0.3, about 3% of verb phrases expand as a past tense verb and a prepositional phrase. Or similarly, we have other rules, so that we have up here a sentence goes to NP-VP rule. And that would have a much higher probability, maybe its probability is 0.4 or something like that. But the really important thing to notice is that these rules make no reference whatsoever to actual words. So this is saying that overall about 3% of verb phrases consist of a past tense verb and a prepositional phrase. But whether that's likely or not depends an awful lot on which verb we're dealing with. So in this example here we have the verb walked, and walked is the kind of motion verb that is really, really likely to have a PP following after it. Whereas if we had another verb, for example, if we had the verb saw, then that'd be a past tense verb, but it'd be really unlikely to have a prepositional phrase coming after it, something like he saw in the mirror or something like that. You'd normally get a noun phrase object after saw first. So it seems like we can only really come up with good probability estimates if we know more about the words in the sentence. And so that's precisely what the idea of lexicalization is. The idea of lexicalization is, let's define for each category a way of finding its head. So for a noun phrase, we'll say that the last noun in it, whether a proper noun or a common noun, will be declared its head. And so for this noun phrase, we'll say that its head is Sue. And for this noun phrase here, we'll say that its head is the word store, because this is the last noun in the noun phrase. And we'll apply that to other ideas. So for a verb phrase, the head of a verb phrase will be the verb inside it. So the head of the verb phrase is walked. And for a prepositional phrase, the head will be the preposition inside it, into. And we'll say that the head of a sentence is the head of the verb phrase. So we put in this way lexical items that represent the head of each phrase next to each non-terminal in the grammar. Let me give my more neatly printed version of that here. Okay, well, what happens if we do that? Well, what we then find is that we've now got these categories like S walked, which are a combination of our old non-terminals plus some lexical item. And so if we do that, we've enormously expanded our effective space of non-terminals, because if we had something like 20 non-terminals before, but we had something like 30,000 words in our vocabulary, well, now we've got 600,000 non-terminals in our grammar. And so that suggests we need to start doing some more special engineering to be able to do that. But let's not worry about that for a moment, and let's just think in terms of probabilities, what this will allow us to do. Well, the neat thing that this will allow us to do is now, if we're looking at what's the probability of this subtree, we won't just be saying what's the probability of a verb expanding to a past tense verb phrase expanding into a past tense verb and a PP. We'll be saying what's the probability of a verb phrase headed by walk taking a PP, and in particular a PP that's headed by into. And so we're now going to be capturing inside the rule two things. We'll be capturing both that a VP walk is likely to take a PP after it, and we'll be capturing the relationship between the heads here. So we'll be capturing the relationship that is reasonable to have someone walk into something. And so we have a lot of much richer probabilistic conditioning being captured by our grammar. This extra information will be really useful for resolving various kinds of ambiguities. So a classic example of that is prepositional phrase attachment. So if we want to work out for a prepositional phrase whether it is modifying a noun that precedes or modifying a verb that precedes, well, we can capture quite a lot of that inside a PCFG once we lexicalize it, because now we'll have a rule where an NP rates is taking on its right-hand side a PP4, and we can ask whether that is a likely thing to happen or not. Or we can say we have a VP announce is expanding on its right-hand side to a PP in. Is that a reasonable thing to happen or not? And so we can use this information to better model PP attachments than we could in a vanilla PCFG. That doesn't mean we can capture everything about PP attachments in this model though, and actually if you want to you could think a little about what other things that you'd like to know about attaching a prepositional phrase which aren't yet captured in this model where we have a head word pinned onto every phrase like this. But nevertheless, this kind of head lexicalization captures most of the additional things that you'd like to know to make the various parsing decisions of a sentence. So it's also useful for things like coordination scope, knowing about the complementation patterns of verbs, and so on. Indeed, it was the case that doing this lexicalization of PCFGs was seen as the parsing breakthrough of the late 1990s. So that's a really useful notion to know about, is this idea of lexicalizing PCFGs to capture more of the necessary probabilistic conditioning information to make parsing decisions.